Okay. So am I audible?
Audible, ma'am.
Okay. So as I was saying that consider a wall, which is a protein, and each protein, one protein is made up of a lot of subunits of the amino acids. So amino acid becomes your subunit, right? Now we know that amino acid is having the structure. Carbon, the alpha amino acid we are talking about, NH2, this hydrogen, and this R. So you tell me, carbon is having R, H, COH, NH2. Is this molecule a chiral or achiral?
This is chiral molecules, different
Because
four
all the
groups attached to
substituents,
the
yeah,
carbon.
all the substituents are different, and whatever the mirror image you will get it, that would be a non-superimposable. Now you understand we started with protein, we cut it down to its basic subunit, that is amino acid, and amino acid is chiral in nature. So when basic subunit is chiral, that means the whole chirality will be generated in the protein molecule. Now the simple question is, which of the following protein structures are chiral in nature? Alpha helix, random coil, beta sheet, or all of the above? Just consider alpha helix is made up of what? Random coil, you saw the structure, it is made up of what? Beta sheet is made up of what? See, the subunits are chiral or not?
All of the above, ma'am.
Yeah, because all of them, they are made up of the amino acid sequences, just their structure or their orientation is different. Alpha helix is having helical motion, beta sheet is having sheet-like of structure. Random coil is not having a fixed structure, but it is having the combination of amino acids. So whenever there is a combination of amino acids is chiral. So there is no further question. They have to be chiral in nature. Okay. Now try the third one. The interaction that exists in beta sheet structure. We saw that beta sheet structure is nothing but your carboxylic group is here and NH2 group is opposite. Like one sheet is having a carboxylic here, amine, that amine carboxylic, like this way it will go. So there would be an interaction, the proton from the oxygen will go and bind with having an interaction with the nitrogen. So this will become a delta positive, this will become a delta negative because nitrogen is having room and is attacking that one. Okay, so when we have this kind of system, that creates a hydrogen bonding. You have seen hydrogen bonding, right? More electronegative atom will take up the hydrogen from the less electronegative. I think this I have made it opposite. So there's an interaction where the electronegative elements are sharing or exchanging the hydrogens, or they create a polarity difference over there that is called as a hydrogen bonding interaction. Whereas in case of alpha helix, in alpha helix we saw that C terminal would be there at one side. So consider this one end as a C terminal. The other end is N terminal. C terminal is nothing but the free COOH group and N terminal is nothing but the free NH2 group. So because they are coiled and consider a spring, you can bring both the ends very close to each other. That will create an interaction. That will create a dipole moment. So in beta sheet, what exists? Van der Waal interactions, which is not having any charge or anything. Dipole moment interactions, hydrogen bonding interactions, or London forces.
Van der Waal interaction.
Are you sure that it is beta sheet I've just drawn over here, right? One sheet is having carboxylic, other is having amine group, and here they are exchanging the proton. One is creating delta negative, other is creating delta positive, and that is, I just told the answer also, that is creating a hydrogen bond. Hydrogen bonding interactions are the actually one which is existing in the beta sheet structure. Why did you say that, why do you think that's a van der Waal interactions? Van der Waal interactions are having any charge?
In charge, but here hydrogen interactions is available.
But van der Waal interactions are not having that permanent dipole moment. They do not have, there would be just a polarizability factor where the electron density is changing. They won't be involving any charge distribution at all. So in this beta sheet, there would be hydrogen bonding interactions, whereas in alpha helix, there is a dipole moment factor because carbonyl and the amine group is in interaction with each other. Is that clear now?
Clear, ma'am.
Okay. So we are moving to the fourth question. So answer this one. how many number of bands appear for the alpha helix in CD spectra? So we saw that CD spectra is helpful in giving you the distinction peaks for alpha helix, beta sheet, and the random coil. And here I will draw the alpha helix for you. So here is the alpha helix. Here is your beta sheet, and this sky blue is your random coil. So orange one, you can consider orange one alpha helix. Green one is your beta sheet. This I've given you for the reference. In exam, they won't be giving anything for reference. So you have to remember this. This is your random coil. Now see the plot. This plot is electricity versus wavelength, which we talked about in the earlier week session. So now tell me how many number of bands are possible or appearing for the alpha helix structure in the series spectroscopy. Firstly, identify which one is alpha helix structure in this particular graph. Is this orange, green, or blue?
Only one, ma'am.
First, answer my question that in this graph, you saw that alpha helix I have drawn with this. I'm highlighting it with red. Okay. So wherever you
Okay, ma'am.
see a peak like this way or a dip, that you have to count. That is your absorbance value. This is 1. This is 2. This one is 3. So how many bands are appearing?
3, ma'am.
Yeah. So 3 is for the alpha helix. Now tell me about this beta structure. Beta sheet is your green one. So I'm
Green
highlighting
one. 1, 2.
2, right? So 1 here, second here. So
2,
beta
2.
would be having 2, right? And tell me
Okay,
about
ma'am.
the random coil, which
2,
I'm
ma'am.
highlighting with, yeah.
That also
Okay.
2.
Now, what is the difference between the beta sheet and the random coil? Is there any difference how they are starting?
Starting beta sheets is starting in a positive
Yeah.
side, but
And
random
random
coil
coil
starting
is
in a negative side.
negative, right? Right.
Negative side. That is the difference. But both of them having only 2 bands appear.
Yeah. And also their ranges are also kind of similar only because they both come, their positive and negative comes in 195 nanometer, and their negative and positive again, they comes under 280 nanometer. So these value also you have to remember. Whereas in case of alpha helix, that's a distinct structure that it will start from the positive, that is fine. But it will be having 3 bands so that you can easily distinct. So all 3 of them you can easily distinct just looking at the spectra from where it is starting, how many number of bands are there. Is it clear?
Clear, ma'am. Clear.
Okay. So try the next one. This also we just discussed that the bands exist for the alpha helix arc. Firstly, you have to see how many bands are existing. So you can eliminate the other options very easily if at all it is there.
Okay, ma'am. Okay. That is A option, ma'am.
Yeah. So we don't have to look for the values also, but there could be a possibility that they're giving in the final exam 2 options where the 3 values are given. But you need to remember that in alpha helix structure, the first positive value appears at 190, another appears at 208 nanometer. There would be a slight change of 190 to 193, and other negative would be at 222 nanometer. Right? So these values you have to remember. Now tell me, see this kind of question I was talking about. The 6th question says the bands exist for the beta sheet arc. So A option is eliminated anyway because we talked about that A is for the alpha helix, right? Now
Okay, ma'am.
talked about B and C.
B and C, both beta sheet and random coil are 2 band appears.
One is for the beta sheet and one is for the random coil.
Okay, ma'am. 195 first 195 nm, C option also 195 nm, both are same, but only
Yeah,
second
this one.
only different.
Yeah.
Second only different. So how it can be identified, ma'am? I don't know.
Okay, so this 280 this value is for the beta sheet. You have to remember this because it is their distinct or the characteristic feature that they are absorbing this value, right? And 230 nanometer, it is for the random coil. Now it is clear?
Okay, ma'am. Now I cleared. 230 nanometer is a random coil.
Yeah, this is random and this is beta and the upper one was alpha helix. So the answer
Okay,
is
ma'am. C
C.
option. C option.
Okay.
Okay.
Now moving towards the seventh question. It's the same question. The three questions are coming from the bands only. So the bands existing for the random coil are. So we already know that this is for the alpha. Looking at the values, these are
Yes,
same
ma'am.
for both
Alpha
the
helix.
cases. The 230 will give you a random coil.
Random.
So option B is a correct option, right?
B is a correct. Okay, ma'am.
Now try the eighth one. This also we just discussed. If the amino acid sequence in alpha helix is comprised of glycine only, glycine we know that it's achiral, right? It is having this kind of structure. Both two units are same, so that can't be chiral. But still alpha helix, whether say if alpha helix is having only the glycine units. So this is having this is glycine because there would be a peptide bond. One COH group or one glycine will be making an NH bond with the other glycine group. That is fine. That would be giving you alpha helix. But if you are having a glycine amino acid in that whole alpha helix, whether your alpha helix will still be chiral. Second option, it will become achiral. So third option, we cannot comment on this. That is not a sufficient information or none of the above. Just understand the meaning of chirality.
Okay, ma'am. Alpha helix is comprised of glycine. Already we know glycine is achiral.
Yeah.
All the sequences are having only glycine molecules.
Yeah.
So it will be achiral, ma'am.
Are you sure? Because I am just saying that chirality, we know that it comes from the helical motion also. We cannot ignore the fact if glycine itself, a certain unit is achiral, but there would be a possibility that this COH free amine and this NH2 amine, they have an interaction. And because of the helical motion, we know now that mu E and mu M vectors are there. So whenever there's a helical motion, that will create a chirality because, say for example, the glycines are achiral, that we understood. But make a mirror image of this one. So I'm just
Okay, ma'am. The mirror image is
yeah.
non-superimposed.
Even if it is glycine, just take a mirror image that will come like this way. Each are having glycine units only. But will that be a chiral or a achiral?
This is chiral, ma'am, non-superimposable mirror
Right.
images.
So, and also because of the C terminal and N terminal, the dipole moment interaction comes into picture that creates a chirality. That's why it will still be a chiral.
Chiral. Okay, A option is correct.
Yeah.
Okay.
And as I was saying, that last question, that is, I am just taking all the possible questions that could be asked in the final examination. So these are just the certain examples. So we have already covered the amino acid sequence. I don't know whether you were there in the meeting or not. I think you joined late at that time. So you go back and rewatch the videos of the professor as well as my live session video, where these letters, the one letter codes are given for the amino acids, and this is your homework. In next class, you will tell me the sequence name. GAVFW, what G stands for, what A stands for, what V stands for. Each information you will give me in the next live session. Is that fine?
Okay, ma'am. One letter codes.
Yeah. So these are normally whenever we talk about the amino acids, they have a long name. So we cannot use the long names everywhere. So their one letter codes are being used. For example, in DNA or RNA also, you will see there would be a combination of GT or something like that. So that GT will define the proper amino acid. You do not have to write each and every full form or something like that. You just need to understand which which amino acid is present. So this sequence is very important. For that, you need to go back and re-watch the videos where you will be understanding which amino acid is having G value, A value, V value, or something. Is that fine?
Okay, ma'am.
Okay. So we are done with today's lecture actually, assignment problems also, and the questions. Is there anything you want me to make you understand? Because we have 1 hour in hand, so we can discuss whatever the clarification you want to have from the last lectures or this lecture particularly. So I'll be happy to answer that.
Ma'am, last time also I understood all the topics. I
Okay.
attended I attended the last assignment 10 question, 9
Okay.
question correct, ma'am,
Okay. That
and
is great. That means,
9 question correct. If I attended the class after that, submit my assignment, I will get
yeah.
good marks.
Yeah.
Otherwise, I will not get it good marks, ma'am.
No, you will get it. It's just that live session will give you, if you are understanding, if you are asking more questions, more doubts are being getting cleared. And if we are done that practice session over here, so this is just a practice session. This live session has been made to have a direct question from you people. So if you are having any single doubt where professor can't be reaching you at this moment, so we are here to help you. So once you have done this practice session and then you are attending the actual assignment problems, just don't think about the numbers at this particular moment. Even if you are not able to answer 5 questions or something, just go back and be consistent for watching these videos. Don't stop watching these videos. This is actually a finishing of your course, right? So you have attended 1 hour thing, and I'm covering all the 1 week lectures in that 2 hours of time. And there you are solving the problems also. That is actually having a good preparation for your final exam. So you do not have to mug up. You can do not have to make notes. You can directly make notes from here. Just watch the videos of the professor and then just practice them. So this would be very helpful. That's why I'm asking if there any other further doubt. There could be many complex questions also in the final exam. So you need to uh, enhance your learning process. Just don't stick to this particular live session video or to the professor. Go back and read the books, the standard books where you can find different problems. Say, for example, the series spectroscopy. Take any protein molecule for that matter. Find out its series spectroscopy. You will get a number of series spectras in Google. Just find it out and then try to solve it by your own. The moment you will try to solve it by your own, there you will understand more. There you will get a proper clarification. Okay, now this I understand. What is alpha? What is beta? What is random? So you do not have to just mug up or just stick to this particular syllabus. That could there could be questions from out of the syllabus also, but be consistent. Firstly, secondly, after attending these live sessions, go back and read from the standard books also. That will enhance your learning.
Okay, ma'am, I will refer to some reference
Yeah.
books
Say, for
related to
example,
this
in case
topic.
of the symmetry one, so I have given all the links in the presentations itself. So there also you can find out the point groups of a different molecules, how are they chiral, whether they are chiral or not. In chiral molecule also, I have given one link where we can see actually in elliptical motion, how the plane polarized lights are going in different directions or something like that. So these are also the things where you can see the real world applications. You do not have to just mug up. I'm saying that it is going this direction. You have to just, okay, ma'am has said it, so it is going like this. No, you can reconfirm by just searching in the Google or watching some other videos or reading some standard books. So that would be very cool. That's why I'm asking if there is any further question from any previous lecture where you have not understood one particular or any question for that matter. There won't be any a complex or basic thing. We are here to help you. So if there is any doubt in today's lecture or session or the previous ones, I'll be very happy to answer that. So you can take time, you can go back to your notes. I'm still here for 1 hour. So you can just let me know is there any question or do you want me to repeat anything? And if not, then you can sign off from this meeting and we will meet in next live session.
Ma'am, in second slide, I think the second slide or third slide, I have one doubt. Please
This
move
one,
the slide, ma'am. This
okay,
one,
we
no
started
doubt,
with this
ma'am. This
one.
one.
This one was the just a pre-cap of symmetry and the mathematics. This was about the chirality, which you already know that which point groups are known as the chiral point groups. Then we talked about the circular diapoism, how we learned about the optical rotation, plane polarized light, whether it is chiral or not. That also we have covered very well. Then we came to the applications of circular dichroism, where we talked about the proteins and then how the proteins, what proteins are made up of. Just understand or remember the brick and wall combination. You will never forget that proteins are made up of amino acids. Amino acids is the basic unit. Then we see that how amino acids are making a chain. What is peptide bond? What is primary structure? That we got to know. Then secondary structure, three particular forms, alpha, beta, random. Then tertiary structure is having the combination of alpha and beta both. Quaternary would be having 3-degree structures, but they would be 4 units, more than 4 units or something. So we took an example like this way. Then I asked like helical motion, where we explained that mu E, mu M vector, where mu E would be giving you a straight line motion and mu M would be giving you a circular motion. So we have to move ahead, but in a circular manner. So that will give you a helical motion. And whenever there is a helical motion, that creates a chiral. Then we saw the beta sheet, and in helical, we saw this C terminal and terminal would be having that peptide linkages, which is creating a dipole moment. Beta sheet, we saw that one sheet is having one molecule, like there would be a total sheet of amino acids, but corresponding to that sheet, one carboxylic group is interacting with an amine group in a hydrogen bonding interaction. So they are having negative and positive charges, which is making a hydrogen bond. And random coil is just like the name random coil, it's random structure. It is not having a certain structure. It is also made up of amino acids, but it's a random. It is not having a defined structure. Then we talk about the three structures, 3-degree structures, which is alpha helix and beta sheet and quaternary. Okay, you were asking something like second or third slide. So did I miss anything here? So I
Ma'am,
start
next slide.
chirality, the
No.
applications.
Third, fourth.
Next,
Next slide. Next.
this one,
No. Next one.
this one.
Okay, ma'am. This one. Primary protein structure. GAV means here, ma'am.
So this is the same question, that 9th question I've given as an assignment, no? So here this GAV is nothing but G stands for one amino acid. These are the names given to different amino acid. A stands for another. So G stands for glycine.
Glycine.
A stands for
Alanine.
alanine. V stands for valine. So you understood that to make our job very easy, they have been given 1-letter codes. And then if you are writing a 1-letter code, that is your sequence. And then you should know that which molecule is actually getting intact with it. Say, for example, if I'm taking a glycine, right? So glycine molecule would be having H here, H this side, and C double bond O here. And this is having your NH2. NH2 group would be, and both the sides, either it should be nitrogen or either should be carbon, carboxylic group. If we have to make a continuous chain, if I'm putting hydrogen at this direction, there would be stoppage of the linkage. So that we can't do, right? So it would be having here NH2, this hydrogen is down, now this OH. Now another group, this is glycine, right? Now we are taking alanine. Alanine is having NH2, CH. Instead of this CH, it is having CH3. This is called alanine, and there would be C double bond OH. And the third one would be a valine structure. So here, if you see this OH and one H from here, it will go out. OH as a OH negative plus H positive from NH2. It will go as a water molecule. And ultimately, this highlighted bond will be like C double bond O NH. This is your peptide linkage, which is a very strong linkage in a protein molecule. So this moiety was a glycine, and this green moiety was alanine. But both combined together to give you a chain structure because of the peptide bond formation. Now you're understanding my point. So the sequence change would be having same amino acids, or it could be having different amino acids. And based on the peptide bonds, make sure that you are drawing the structure in this particular manner, that either it should be an N-terminal, or should be a C-terminal. It can't be H or R group on that side. H or R group has to be go like up and down. So for the continuation of the chain, it should be either N-terminal and the C-terminal. Now is it clear?
Clear, ma'am.
Okay. Is there any question apart from this?
Next slide, ma'am.
The next slide, we were talking about the secondary protein structure, where we already talked about the alpha, beta.
Okay, ma'am. This is okay. I understood.
Then we, as I was explaining, helical motion, we know that mu vector. So
Already I know in previous
yeah,
classes
previous
also.
class also we talked about the beta sheet structure. Okay, so this would be having this combination. So as I was saying, so there would be GAV, these amino acids, GAV, another. So one sheet, second sheet. So they would be having interactions with each other. Based on that, hydrogen bonding interactions are there. So that kind of things make the beta sheets. So one sheet, another sheet, third sheet, fourth sheet, like this.
Okay.
Okay. And random coil, as
Oh,
its name suggests, so it is a random thing. Like it is not having any certain structure, just like a thread. You can turn it, coil, turn it anyway. So it is not having a
it
fixed structure.
it look like a coil structure.
Yeah. Then the tertiary structure. Tertiary structure is something which is having a combination of both alpha helix and the beta sheet. Okay.
Okay.
And the quaternary also we talked about, it would be having different subunits of the 3-degree structures.
Yes, ma'am.
So
Myoglobin and
yeah,
hemoglobin.
myoglobin and hemoglobin are two this metalloenzymes where myoglobin is having only one 3-degree structure, where hemoglobin is having 4 subunits. So what 4 subunits? First,
Ma'am, quaternary structure also contains both the alpha helix and the beta sheets.
yeah, but
Uh, but
see,
it's having it is the example for myoglobin and hemoglobin. Myoglobin having a 3 subunits.
one unit,
Hemoglobin.
one unit which is having only 3-degree structure, and hemoglobin is
Oh,
having 4
okay, okay.
subunits.
3 degree, 1 unit, 1
Yeah,
subunit.
3 okay, myoglobin, you can understand. Firstly, 3-degree is a combination of both the alpha and beta sheet. And myoglobin is having only one tertiary structure. Don't consider it as a 3-degree or something. Okay, so it is having only one, one unit, which is a 3-degree or tertiary structure. That tertiary structure is comprising of alpha helix and beta sheet. Whereas in case of the quaternary, it is having just a block where 4 subunits are there, and each subunit is a 3-degree structure. Is it clear now?
Clear, ma'am, clear.
So you can go back and check the myoglobin and hemoglobin. Just read about it. You will get to know about the combinations. So for example, hemoglobin would be having alpha, alpha, beta, beta structures. So this, I'm not going into full details because that is out of syllabus. This is not going to be helpful much. So we will stick to the circular dichroism. Is that clear? Hello? Okay, so this was the next question, that how do we identify that protein structure? Okay, we know that alpha form, beta form or something, but what is that spectroscopy which can help us to identify the structure? So this was clear that single crystal XRD is going to give you only one single structure, but we know that proteins exist in a lot of structures, primary, secondary, tertiary, quaternary, but how do we identify that? So not X-ray would be a good tool, circular dichroism would be a good tool. And we already talked about the circular dichroism in the last section, where dichroism means 2 absorbances. Based on the absorbance difference between the LCP and RCP, we can see the CD spectra. So is there any doubt in these slides?
No doubt, ma'am.
Okay. Then we talked about this also. I think it is clear to you now. What is alpha, how it looks like, how many number of bands are there. Alpha would be having 3 bands starting from the positive, going to the negative region. Beta is having 2 bands starting from the positive to negative. And random coil starts from the negative, goes to the positive. You need to remember the values of these absorbances so that you can mark the correct option. Okay.
Okay, ma'am.
Then we went across and we saw that why we are talking about these absorbances already. Because as we said that amino acids combination that is making a peptide bond, and peptide bond is having carbonyl group and the NH group. This carbonyl NH group is having two kinds of electronic transitions from N to pi star. N is nothing but the lone pair is coming into the making a double bond with carbon, and oxygen, the double bond is going above and it is creating a negative charge on this bond is going above and this is coming back. So that is called N to pi star, and that is having an absorbance from 210 to 230 nanometer. Whereas if I talk about the C double bond O, that is a pi to pi star transition. This is just a basic, if you'll just go back and cross check the UV spectroscopy electronic transitions, you will get to know about all of that. So they are having 180 to 200. So that's why all the CD spectroscopy that absorbance values are lying from the 180 to 230. They're not going lesser than that, and they are not going uh, above than that. Is that clear?
Clear, ma'am.
Oh. And then we talked about different factors on which CD spectra will depend, like different structures would be having different distinct features. Even if we are changing the pH, going from acidic to basic, basic to acidic or to neutral, that would be a change of the protein structure that would be easily seen in the CD spectra. Also, the temperature, consider and remember the example of the egg. When we are boiling the egg, the liquid inside the egg is getting solidified. That is a protein only. And that protein is going from its natured form to a denatured form. It is a denaturing of its form. So it is going from liquid to solid state, and that is because of the temperature effect. And then we talked about the TM. TM is a melting point where both the forms, nature form as well as the denatured form, exist in the equilibrium. For example, in egg, there is liquid form, there is a solid form. Both will be existing in a same time. You might have seen that some liquid and solid is going to come if at all you are seeing that egg boiling. So that will be coming out of that egg. It has not gone to completely solid form. It has not gone to the complete liquid form, but some intermediate state is there. That is a temperature where both the states are existing similarly, like equilibrium. So that was all about the splice issue. So is there any doubt?
No doubt, ma'am.
Okay. So if you do not have any other query, you can sign off. Otherwise, I can just take up any further doubt you are having.
Ma'am,
And don't
today live session is ma'am, today live session is complete now.
Yeah. Today's live session, I'll be just waiting for if any other student will come in between and has any question, I can explain to them. If your doubts are clear, then you can leave the live session. You can just go back and just try the assignment problems and see whether you are able to understand. But first, watch the videos from the professor also, because all the things have been covered in details in his slides. I'm just taking up the basic concept. So in 2 hours, I'm completing everything. So yeah, you can do that. And also regarding the character table, I'll make sure that once the 12-week live sessions are over, I'll be having one more live session where I'll be discussing the character table. That would be a special class for character table, so that you will be having more emphasis on the how to define, how to get the character table. You do not have to mug up anything. Okay. Is there anything else? Hello? Hello? Am I audible?